All right, so we just talked about a multiplication table. Sorry, let me get this up and running. So multiplication table 1, 1, 2, 3, 4, 5. I'll just go that far. 1, 2, 3, 4, 5. So I'm only going to fill it in along the diagonal. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So if I asked you guys the square root of 25, well, we know that 25 is just the same as 5 times 5, which is just the same as 5 squared. And here's the way it works. Now, a lot of you already know the square root of 25 is just 5. But what we're essentially saying is that this square root right here and the squaring are inverses of each other. So they're going to kind of cancel each other out. So this and this kind of cancel each other out, and all we're left with is 5. So another way of thinking about this is if I had the square root of 16, that would just be the square root of 4 squared, and these kind of cancel each other out, and we're left with 4. So these perfect squares are going to be really important because now I'm going to ask you the square root of 52. All right, now if I just plug this into my calculator, the square root of 52, and if you have a calculator on your phone or nearby, you can plug that in. In fact, here's what I want you to do. I want someone to plug in square root of 52 into their calculator and just write it on the screen next to that equal sign. All right, thank you, Connor. So yeah, we can see that it's got the 7.21 and it goes on from there. Now this is not what we want to do. This is not simplifying this radical. So what we want to do instead is we want to rewrite this in using perfect squares. And so if I look at this, I can see that 1 is a perfect square, but that one doesn't do us any good, honestly, because you'll see what we're going to do here. I'm going to try 4. Now, if you're familiar with decks of cards, you already know that 4 is one of the factors of 52 because there's 4 suits, 52 cards, 13 cards in each. So you can do this real quick. Just 52 divided by 4 gives me 13. So I can rewrite this right here as 4 times 13. Oops, that happens sometimes. Okay, 4 times 13. And again, all I did was 52 divided by 4, and I got my answer 13. So that tells me 4 times 13 is 52. Now, here's one thing we can do with radicals, is I can split this up. So 4 times 13 under the radical is the same as the square root of 4 times the square root of 13. Now, why did I do that? Well, I did that because 4 is a perfect square. And I already know that the square root of 4 is what?
2.
2. Very good. Thank you. So I can rewrite this as 2 times the square root of 13. And at this point, I don't think there's anything else I can do. 13 is a prime number. You might already know that. Maybe you kind of go through and figure out some other factors. At this point, if I look at it, well, 13 and 1 is a perfect square, but if I take the square root of 1, it's just 1, and it doesn't change anything. So that's why we don't care about 1. But anyways, at this point, this is my simplified radical. All right, so hopefully that makes sense. We're going to do a few more examples. I'll do the square root of 96. All right. And the square root of 96. Now, I don't automatically know. Maybe some of you can figure out how this will simplify. But here's what I'm going to do. I know that 4 is a perfect square. And it seems like 4 should go into 96. So I'm going to do 96 divided by 4. So 96 divided by 4 is Hey, that works nicely. It's 24. If I got a decimal number, I couldn't use it, but this one worked out perfectly. So I could rewrite this as 4 times 96, which this becomes the square root of 4 times the square root of, sorry, that should have been 24. I apologize. 4 times 24. So this is the square root of 24 right here, and the square root of 4 is 2. All right, so I'm sorry I misspoke a minute ago, but 96 just turns into 4 times 24. All right, now I feel like I'm not done yet because I feel like 24 could be split up even further. And can anyone quickly find some factors of 24 that involve a perfect square?
Would it be 4?
4 times what is 24?
Oh, 6.
There you go. Good job. So I can rewrite that as 2 times the square root of 4 times 6. So again, I can show that as 2 times the square root of 4 times the square root of 6. And I know the square root of 4 is 2. So it's going to be 2 times square root of 6. And remember, the square root of 4 became 2. And then that gives me, now I need to actually multiply these two together. So that's 4 times the square root of 6. And that is as simple as it can get. Because if I start thinking about number 6, is there anything else that's a perfect square of 6? And no, 4 is my smallest perfect square that matters. And that's not a factor of 6. 4 times 1.5 works, but 1.5, I don't want decimals. I want whole numbers. So in the end, this is as simple as it gets. So these are equivalent. All right, so we're starting off with just simplifying radicals in this form. And I want us to get really, really comfortable with this. And the reason being, we're going to be working with radicals later in the year. And what I've found is that when we get to that point, if I don't do anything until we get to that point, then students really, really struggle with this idea. But what we're going to be doing is just practicing these concepts every single week. And by the time we get to where we need to use it in class, you are hopefully really fluent at it, you're experts, and that goes really smoothly and you guys ace it, okay? So I'm starting you now on something that we're not gonna see for a while. All right, so let me leave this real quick and take us over to Delta Math. Oh, before we do that, I want everyone to raise their hand and let me know that they are here. I'll do this periodically during lessons. It won't just happen one time. So you'll need to make sure you're sticking around and staying actively listening. There's a number of people who have not raised their hand. I don't know if you're here or not. And once everyone's hand is raised, I'll lower your hands for you. So don't lower them until we're good to go. Okay, so this is what it's going to look like when you pull this up. And you're going to get a random radical, and you're going to need to figure out how to split this up. And we're looking for a perfect square. So that's why you're going to want to refer to that multiplication table if you don't know your perfect squares very well. Now, we do know that 1, 4, and 9 are the first 3. Again, 1 doesn't matter, so you can just skip that one. So 4, 9, 16, 25, and so on. So I'm going to try 4. 162 looks like it should be divisible by 4. So if I do that, 162 divided by 4 is 4 times 40.5. So I get a decimal, and I don't like that. So I can't use 4. So that one doesn't work. So then I'll just go to, there you go.
It's 18.
I'll try not, say that again.
If you do 9, you get 18.
There you go. So yeah, if you do 162 divided by 9, thank you very much. You get 9 times 18. So that works. So here's all I need to do. And luckily, this is kind of guiding you through the full process. So I'm going to try 9 and 18, and it'll let me know. So let's say I didn't do that correctly. Let's say I tried 4 and 40.5. Here's what it's going to show me. Nope. Well, first of all, it won't accept decimals. And so that's already going to tell me, okay, I did something wrong. So anyways, now we try the next one. 9 and 18. And that worked. And so if it moves to the next line, then we worked. Now the square root of 9 is
3.
3. This is square root of 18. I'll just leave it as is. Okay, now if I was completely done, it would give me a green check mark. It would say, you're done, good job. But this is telling me there's more I can do. So what factors of 18 can I split this up in to still have a perfect square?
6.
6 and 6 times what?
3.
3. So let's try that. Whoops. Neither of these are perfect squares. Okay.
9 and 2.
9 and 2. There we go. Look at that. 3 times 9, square root of 9 times square root of 2. So what is the square root of 9? Well, we just did this one. Square root of 9 is 3. We know that. And 2. So there we go. So it's just going to keep going step by step, and it'll tell you when you're done, because it's kind of hard to know if you've done it 100% when you get started. But this walks you through and lets you know when you're 100% finished. So now 3 times 3 is 9, square root of 2, and we're done. We submit our answer, and it says, good job. Okay. So so this is what we just did down at the bottom. But maybe we could have figured something out differently. Maybe we recognize that 81 is one of the factors of 162. And we just did 81 times 2, and then we could just get it done kind of in one step. It doesn't matter if it takes us 1 step or 2 steps like right here. What is important is that we get to the correct final answer. Let's just do one more example, and then if you still have questions after that, you can stick around. 176. Okay, so let's just, we can do this 2 different ways. We can try and find the biggest perfect square factor, or we can just go with the smallest one, and the smallest one that works. So I'm going to try. I'm going to see if I have an inkling that 4 will work, you know? So maybe we can just start with that. It's always easy if you want to just start at the low end. So let me get rid of all this work. We can start fresh again. So if we start with 4, 176 divided by 4 is 44. But I'm not even going to do that one. I want to go a little bit higher. I'm going to try 16. I don't think 9 will work. I could try it. 176 divided by 9 is a weird decimal, 19.5 repeating. So I don't want to do that. So I could do 4 times 44. I could do, 9 times 19.5 repeating. So that one's not going to work. I'm going to try 16. 176 divided by 16 is 11. 16 times 11. And you know what? I like this one. So I'm going to plug that in. 16 times 11. And that worked. It accepted it. And now I know the square root of 16 is what?
4.
4.
4. Perfect. So now I get 4 square root of 11. And I'm pretty sure that's all I can do. And notice it doesn't give me an option to keep going. So that's telling me that there's no factor of 11 that's a perfect square. And that's a prime number. Most of you probably already know that that's about as simplified as we can get. I'll submit it, and we're done. And that was the fastest path this time. But again, if you just did the 4 times 44, it would keep prompting you to keep going until you got to this anyway. So regardless of how you do it, that's kind of the process. If you have any questions, we can go through more examples, but if you feel like you understand it, your homework is going to be doing 5 of these, and they're all going to be randomly generated. So I want you to run through those 5. And if you have questions on how to get your Delta math working, things like that, we can also work through that. So at this point, I'm going to call it a day. If you have any questions, stick around, but otherwise, have a great one. I'll see you tomorrow.